This handout was sent to everyone in the course. So today's topic is geospatial data. Basically, what does that mean? This is helping you make decisions based off geography. So, for example, geography is going to be very important. So, for example, I went into the local Walmart and they have a lot of t-shirts for LA Dodgers. Okay, well, living in Los Angeles, that's not surprising. I didn't see the only two I saw were the LA Dodgers and the LA Angels. What about like the Milwaukee Brewers? What about the Florida Marlins? I don't think I've ever seen that. Those t-shirts or jerseys or anything associated with those two in my local Walmart. So again, the geography makes a big impact on the type of decisions that businesses will make. Okay, a couple years ago, I went up to the state of Washington. I went to the Walmart there and I saw a lot of sports souvenirs, t-shirts, so on and so forth for the Seattle Mariners because I was in the state of Washington. I didn't see anything else. So again, geography then will be a big component when businesses go out there and make certain type of decisions. So this is called, in business, this is called geospatial data analysis. And really, what is the driving factor when making some type of business decision? It's the geography. It's the geography. So we want to go over different maps because maps and geography go together. And then to complete today, we're going to put together one of these maps. But there's a variety of maps that we want to cover, and let's go over these in detail. So the first one is called a choropath map. So you're used to these choropath maps. You probably didn't know what the name was, but you've seen these all the time. What is a choropath map? A choropath map represents data using different colors or shading patterns for different geographic regions. Each color or shading patterns corresponds to a different value or range of values that a particular variable can take. Choropath maps are great for intuitively visualizing geographic clusters or concentrations of data. However, a choropath map could be misleading if the size of the region overshadows its colors. Big regions naturally attract attention, so large areas might get undue importance in a choropath map while small regions are overlooked. So you see examples then of a couple of choropath maps below here. So the one on top is for the state of Alaska. And to be honest, I'm not sure what the different colors regions represent. Again, I have no idea. I'm sure they represent something, but I don't know. I just thought it was a good map as an example to use for this lecture. The one on the bottom is another choropath map. Again, I don't know what the colors represent. I don't know what the colors represent, but I thought it was a good example to bring up in this class. And you could see that it's a map of the United States. And to be honest, I can't even hazard a guess as to what the colors mean. Okay, so there's probably some significance to the different colors that were used in this choropleth map, but I just can't tell you, and I apologize. But I think you get an idea of what a choropleth map looks like. I have other examples coming up. So on the top two maps there, I have choropleth maps of different parts of California. So you can see there on the top left, the map with the yellow, green, blue, and kind of a purplish area, map of California. And that map seems to be focusing on the coastal regions of California. Let me make this a little bit bigger too. Okay. So the coastal region, I see a couple exceptions there, but basically this yellow one is the coastal regions of Northern California and above. Nothing in the green area, nothing in the blue area, nothing in the purple area. Next then, I show a map there to the right of Southern California, the different counties that constitute Southern California. Okay, and so you can see how the map on the right would fit into it like a puzzle to the map on the left there. And again, these are just different colorings applied to different counties in the Southern California area, and the one to the left is the Northern California area. Okay, so why the difference between the green and the orange on the right side? I'm not sure. I'm not sure. Okay, and to make it a little bit more distinguishable between the different counties, I think I would have mixed up the green and the orange if the colors weren't that important. But again, good examples of choropleth maps. You've seen these types of maps often. And again, they're good at providing whatever type of information visually. And if we look at this map of Southern California here, we see here, if you look where I'm circling with the cursor, we see San Bernardino County. And if you weren't aware of this, but geographically, from a geographic standpoint, San Bernardino County is the largest county in the United States. Largest county in the United States. We're talking in terms of area, not population. San Bernardino County is fairly sparsely populated. A lot of it is desert. If you look, again, this area right here, going into Nevada and Las Vegas, all these areas on the eastern part, almost all desert areas. So I'm just hazarding a guess here, but you see Orange County in Southern California, Anaheim, Irvine, Newport Beach, some of the areas that you may have heard of. I bet the population in Orange County is 5 times greater than San Bernardino County. Okay? Much smaller area, much larger population. And let me go down here. And I have another choropleth map of now the greater Los Angeles area. Here you see San Bernardino again, and this is the start of San Bernardino County. And what is the significance of this chloroplath map? You see the green areas in this greater LA area. What do the green areas represent? They represent the mountains. They represent the mountains. So you don't see too many cities located in the green areas because basically they're very mountainous and not habitable, not habitable. You know, at this point, they can, if they put enough effort into it, make it a community, but not really. The only city you see within the mountains in this chloroplath map is Big Bear. And Big Bear is a resort city where they have skiing during the winter, some of the best skiing, I think, in all the United States. And also during the summer, if you look here, you have this lake where there's a lot of water sports done on the lake. But again, this chloroplath map, what's the significance? It's the green areas. And the green areas are showing the mountainous parts of the greater Los Angeles area. Now, let me make this one a little bit smaller. Now, if you remember from your assignment for this week and talking about the 405-101 interchange, basically the California government agency that handles all of the highways in California, this is called Caltrans. The California Transportation District Authority, I'm not sure, but it's called Caltrans. And what Caltrans does then is that it breaks out the different counties into different clusters, regions. So you see to the top left there, where you have Eureka, the bluish area, that's region 1 of Caltrans. And then going to the right, in Redding, California, that's region 2. Okay? And then you can go down. Region 3, you can see region 4 is the Bay Area. Coming down on the region 5, San Bernardino, Santa Barbara area, San Luis Obispo, and then down near the bottom here in the dark brown area is Los Angeles, that's region 7. San Bernardino County, which we just talked about, along with Riverside County, is region 8. Okay, you can see region 9, region 10, and region 11 is San Diego and Imperial County. Region 12 is Orange County, which we talked about. Region 7 is Ventura and Los Angeles County. So again, this is a chloroplath map, and the areas are not contiguous, which means that basically you see here, how come region 10 isn't right next to region 11? I'm not sure. That's just the way they went out there and divided up the map to use the colors to distinguish the different areas. But a real nice chloroplath map. A real nice chloroplath map. Let me make this one a little bit bigger. So again, we're not just limited to just our planet. Here's another map, chloroplath map, but this is of our solar system. This is of our solar system. And you can see how the different colors are showing different planets. Okay? Showing different planets. And what does the white in this choropleth of the universe show? These are all the main asteroid belts that we have in our solar system. So there's the main asteroid belt, and there's also one called the Trojan asteroid belt. And I think the Trojan asteroid belt is within the orbit of Jupiter. Okay? And then the next one that we have here, this is the map, I think, of our universe, the Milky Way. Oh, I should say, not the universe, but our galaxy, the Milky Way. And it's showing cosmic microwave background radiation. So this is then of our galaxy, and I think it's just showing, you could see there that the colors are just showing different, I think it's intensities of background microwave radiation within the Milky Way galaxy. So you can see that the choropleth maps aren't limited to just small geographic areas. Doesn't get much bigger than our galaxy. Doesn't get much bigger than our galaxy. But the principles of the choropleth maps still hold. Okay, now the next type of map that we want to discuss are called heat maps. So heat maps are useful when you have to represent large sets of continuous data on a map using a color spectrum, usually red to blue or red to green. A heat map is different than a choropleth map in that the colors in a heat map are not limited to geographic boundaries. Heat maps are useful for identifying patterns, especially hot groups or regions of high concentration of the variable. Heat maps must be used cautiously to keep data accuracy intact. Building heat maps typically involves using algorithmic extrapolation logic to create a continuous field of colors, often because the data sets are discrete. Therefore, the data at any particular point cannot be 100% reliable. And what does that mean then, right? Basically then, they have, if I was going to look at this map of California here, is it continuous? No, they have dots, basically, that make up the brown area, the red areas, so on and so forth. Okay? But they have to extrapolate to show that it's continuous. They don't have data across the whole spectrum. So they make an educated guess to connect the different heat areas. Okay, so on this one on the left here, what does this show? Basically, it shows elevation. So you see here then, we have this blue area, this blue area here, the blue areas. What do the blue areas represent here in California? Okay, they represent the low-lying areas. Whereas these more rugged-looking areas, what do they represent? They represent the mountainous regions of California. So that tells you then, just looking at these maps, you probably know that this blue region for California is called the Central Valley. And one of the most productive agricultural areas in the world. You could see, if you remember how big California is, you can see that the Central Valley is a very large area of very fertile land, Okay, and then I don't want to make it too much larger, but you see down here, okay, in the Orange County, LA, and Ventura County, another blue area, another fertile region for agriculture. And then finally, the Imperial Valley area that is just north of Mexico. You can see here that these are low-lying lands and also another fertile agricultural area in California. What about the mountainous regions? No, almost nothing in terms of agriculture. Okay? They're good for winter sports, but that's about it. There's not much done in the mountainous regions of California. And as you might imagine, when you look at the coastal regions, the LA and the Bay Area, San Francisco, Oakland, they're all going to be low-lying areas, and they contribute a lot to the ports in the area. Okay, now let's look to this map on the right here, and this one then is a heat map that shows crime in California. And if you look up here, where you look at what the spectrum is, light brown is low crime, going up to red, deep red, okay? Those represent the deep red, brown, they represent very high crime areas in California, okay? And so you can see then that there are some parts in California, almost white, very, very low crime. Probably because there's not too much, these areas aren't highly inhabited. But you look down here in the Los Angeles area, and around here, boy, it's the deep, deep brown, right? Very high crime areas, and extending well out almost to state of Nevada. So that, from here to here, probably about 200 miles. And unfortunately, 200 miles of high crime. Okay, and some of the unfortunately, there's a lot of dark brown areas here. Okay, but again, remember, this is Los Angeles, California, and unfortunately, the crime is way too high in these areas. These areas make your Gary, Indiana look like a Sunday picnic. These areas tend to be horrible in terms of crime. And unfortunately, only getting worse, but I'll stop there. Okay, I'll stop there because this is a political comment, especially since this is election season coming up in California. Now, I'm not sure how accurate this map is, because up here, right here in the Bay Area, that's Oakland. And I know Oakland is another very high crime area. Okay, so how come that's not deep brown or almost black? I'm not sure. Okay, but this only goes to prove, especially down here, of unfortunately the high crime rate that we have in Southern California. The heat map depicts that perfectly. The heat map is a perfect depiction of the volume of crime in the Southern California area. Okay, so here's another, I like this map a lot. This is a good map. Okay. And what it does then, what this map does through a heat map is that it shows what the average prices of houses are in different states in the United States. So you go, it's going to start at the bottom here where it's just a light pink, move up the spectrum, spectrum. So it's going to start at less than 150,000 and move all the way up to greater than 300,000. Greater than 300,000. And you can see here that the heat map gives you a very good idea of where some of the more expensive areas are in terms of housing prices for the United States. So again, obviously, I'm going to focus on California. All right, second behind Hawaii. We know that Hawaii prices are ridiculous, but this heat map shows that California, Nevada, houses here are expensive. Although I look at this price, 532,000, boy, I don't know where they get that number from. It seems a little bit low to me. In California, I don't know where you can buy a house, especially in my area, for 532,000, and I don't live in a nice area. Okay, never touch a house for 532,000. Okay, but this heat map is good. This is a good map to show in terms of housing prices. The heat map is a perfect depiction of housing prices based on this spectrum right here. You can see where my cursor is pointing based off that spectrum. Okay, so here's another map here. Here's another map here. And what is this map basically? You see, these are new and refinance mortgages, okay, with payment, and they got financed with payment options. Basically, what are these? These are the houses that are being defaulted on. They're defaulting on their home loans. So again, the heat map is a good way to show the percentage of houses that are being defaulted on. And where do we go? Where do we go again? Okay, which has the quote hottest areas? Well, as you might imagine, California. All right, if our housing prices is about 530,000, you could imagine that a lot of people are defaulting on their loans, unfortunately. Okay, again, up here, we saw that the average price of a house is over 530,000. I think this is low. Okay, but that corresponds then into a higher defaulting on their mortgages in California. Because the houses are so expensive. The houses are so expensive. Okay, but this heat map is very, very descriptive. I have another heat map here of the United States, and that shows all of the based off electric vehicle charging stations. And it seems like if you looked at this heat map, where is the highest cluster of electric vehicle charging stations? It's by the major metropolitan areas. By the major metropolitan areas. So you see a lot here, again, from the Bay Area down to Southern California, all along, okay, this Northeast corridor, Chicago, Atlanta, Dallas, all these areas have a high concentration of electric vehicles because they probably have the most electric vehicles. So they have the most charging station. The heat map gives us a good idea. Okay, and then I'm looking at this map here. Okay, and this is for Australia. And what does this heat map show? The concentration of alligators, I'm sorry, concentration of crocodiles in Australia. So we know that the crocodiles, they'll go from, especially the big saltwater crocodiles, they'll go from Australia all the way, all the countries in between, all the way up to India. And they're not called saltwater crocodiles for nothing, because they can cross the ocean, something that our American alligators cannot do. Okay, and I was just reading in this area, there's a problem with feral or wild hogs in the northern part of Australia. Because of that, the population of saltwater crocodiles is healthy, or even more than healthy, because they eat a lot of those feral pigs. But I think in many of these areas of Australia, no swimming, because too many crocodiles, mean crocodiles, will eat people. Okay, now the next map that we have here is called hexagonal binning. And hexagonal binning is good because what they do is they'll break out your clusters into small hexagons. Why are those hexagons good? Because the hexagons can be pieced together without any bare spots in between. Okay, so it's kind of like a heat map, but how do they go out there and put together that heat map? They're using these little hexagons. So hexagonal binning is a data visualization techniques where you can create a grid in your map with regular hexagons. Once the grid is created, the map can be colored or shaded like a choropleth map. This map represents the changes that took place in individual constituencies. Each constituency represented by a hexagon from the 2005 union election to the one in 2010. Creating hexagon grids is useful when you have a lot of granular or small data points, but you do not want to compromise on accuracy that use data extrapolation techniques. You don't want to guess in between. The hexagon is a preferred shape because it is close to a circle, but unlike a circle, you can form continuous grids with hexagons. However, it becomes difficult to zoom in or zoom out of visualizations by dividing hexagons or aggregating them. So let me make this a little bit bigger. I think this is a map of England. And, you know, I'm not sure too much about English politics, but I think this is basically like a choropleth map of the different political parties they have in England. But you can see, if I make this bigger, that basically, what is this? It's a consolidation of hexagons. And ultimately, it looks like a choropleth map, okay? But because the hexagons fit in like puzzle pieces, it gives a more accurate depiction of your data. So nice, you could see that all of the dots basically are hexagons, all fit in nicely together. That's the benefit of a hexagon binning map. Next one here is one that you've seen often. A dot map uses a dot to indicate the presence of a variable. Dot maps are essentially scatter plots on a map and are useful for showing spatial patterns. This is a dot map of the world showing about 700,000 Wikipedia articles by region, by geography, each represented by a yellow dot. A dot map gives an accurate representation of the value of the variable in granular locations on the map. To ensure location accuracy, it's important to geocode the data accurately during the collection period. Okay. So you can see here then that large parts of the United States, southern Canada, west coast of the United States, some parts of South America, almost all of Europe, India, the eastern coast of Australia, Japan, South Korea, Indonesia, a lot of Wikipedia articles in English are coming. Each one represents an article that came from that area. Okay. Here's another dot map of the United States. What it shows, I'm not sure. I didn't get the title or label for this map, but I liked it because it's a nice map here. Another one of the United States. Okay. Cluster maps help represent dense pockets of data points using a single point. Each cluster is either then relatively sized, so it's going to be bigger or smaller, and labeled with the number of points that have been grouped together. So right here, we have a cluster map of Appalachia. Okay, and so northern, southern, what these regions represent, these are clusters within the Appalachian area, the Appalachian Mountains. Okay. Here's another cluster map that I chose of the Los Angeles area. And again, what do these represent? What do these represent? These represent foreclosures in the greater Los Angeles area. So some areas, like right here, okay? How come we don't see any clusters? Very low population density. But here then, you can see the different clusters. Here's another cluster map showing dinosaurs. Here's another cluster map. This one looks a little bit blurry to me, but here's another cluster map. And again, I don't know what the label of this cluster map is, but it's showing California and the United States. Next one here is a bubble map. Bubble maps help represent two variables, one by varying the size of the bubble and one by varying the color, simultaneously in a single visualization. Bubble maps help viewers make sense of three parameters at once through the location, size, and color of the bubbles. You must be careful while creating bubble maps that may contain small geographic regions to avoid overcrowding the bubble. So here's a bubble map of the United States. What the bubble maps represent, I don't know. Because you could see here the biggest bubble is in Florida, and then second is Texas. What are these bubbles of? I'm sorry, I don't know. But it was just such a cool map that I had to include it in our presentation. Okay, and in this one, this is another bubble map, location, size of the bubble, different colors. So bubble maps give you 3 bits of information: geographic location, intensity, okay, and using the different colors to represent different parameters. You're probably used to bubble maps. Okay. In a cartogram map, the mapping is in diagrammatic form. Okay, and what happens here is that the country or location is made bigger or smaller based off some type of parameter. Okay, so you could see here then that, you know, this doesn't represent, you know, we know that India isn't this big geographically. We know that China isn't this big geographically, but what is it showing? These are bigger based off of their populations. And we know that China and India have the largest populations. I think this one for the United States, I guess it's big enough. But remember that, you know, China and India are first, and then a distant third is United States. We have a population about 1 billion less than India. And then you see like other ones, Japan here, the European countries, proportionally bigger based off of their populations. Nice map here. Nice geospacing of the map. Okay. Here's another one, cartogram based off a parameter. I don't know what this is. Okay, but it shows here that in relative terms, California is the biggest. Looks like New York, Texas, Florida. I'm not sure if the colors represent anything, but it was a cool map, and I wanted to include it in our presentation. Here's another cartogram, okay? And what does this show? The number of representatives in the House of Representatives. And again, proportional based off the number of representatives. Okay? So we know then that Nevada is a big state. New Mexico, geographically are big states, but small on this cartogram because they have such a low population density. Here's another cartogram that shows the distribution of Republicans and Democrats, with red being the Republicans, blue being the Democrats. So this is a cartogram. A flow map is a type of thematic map that uses linear symbols to represent movements. It may thus be considered a hybrid of a map and a flow diagram. I should have underlined that second sentence. The movement being mapped may be of anything, including people, highway traffic, trade goods, water, ideas, telecommunications. The wide variety of moving materials and the variety of geographic networks through which they move has led to many different designs. So I'm not sure if this one could be trade or exports that the United States makes. Okay. This one shows all the lumber coming from British Columbia, Canada to different parts of the world, and the width of the arrows show the intensity of that flow. Okay. And this one then shows, this was I think one of the first of these flow maps, they show the amount of troops going from in the 1812 French invasion of Russia. Starts off big, but going across Europe there, you see that when the French finally hit Moscow, much less people, much less military than when they first started. And the black is when they went back. Look at what they ended up with. Okay, one of the first flow diagrams that was a pioneer in this area. Again, here's our universe. This is from the Big Bang, and then going then to where it started from, all the way to basically where we are now, with the size of the universe getting bigger. And these are like really small numbers. So, I mean, this is like 1/1,000,000th of a second, 1/10,000,000th of a second, 1/1,000,000th of a second, so on and so forth to get here with what is our universe? 14 billion years old. So from when it first started all the way to the size of our universe. Same one, same type, okay? So the Big Bang plus 10 to the minus 43 seconds, 10 to the minus 35 seconds. How they figure that out? I'm not sure, okay? And then all the way then to 14 billion years after the Big Bang, and that's where we are now. And you could see here from about 380,000 to 14 billion years, this is where all the stars, planets, and the galaxies began to form. Flow diagram. Okay. Again, flow diagram. That was our last one here. I picked this one because of this basketball player, Derrick Rose. And basically, he's the map. He's the map. And this is showing then all the different injuries that have really been a detriment to his career. Good player, but the injuries have gone out there and sapped him of much of his ability. So maps aren't related to just geography. Here is one of this basketball player, Derrick Rose, okay? And he's the map. If you can look at this because you have this handout and you can see the map of his injuries. Okay, so let me close this real quick. And let's just do this exercise. Let me make this smaller. And this is going to be similar to your homework, okay? And what I wanted to do then was just to show a dot map. And we want to then look at all of the different sports teams in California. But it's going to be too much, so let me just pick some. I'll just pick all the baseball teams. So here then, again, we want to do like a dot map or a type of cluster map. And so here in, let me move it to right here. These are the San Francisco Giants. And then on the other side of the bay, put the Oakland A's. And then here, down in Los Angeles, I'm going to, where are the Dodgers? Okay, I'm going to put the Dodgers. Here in this Los Angeles area. And then the Angels in the Orange County area. And then finally the Padres. Where are the Padres? San Diego Padres. We'll put them here. Okay, and you can see I have a lot of other sports teams that I wanted to use to construct this map, but you get the point. You get the point. Okay, and as you can imagine, if I was doing it for Los Angeles, it's going to get really crowded because I have still the Lakers, the Kings, the Clippers, the Rams, and the Chargers just to put in this area. How would I have done that? I'm not sure. I'm not sure. Okay, the Ducks would go right here. That wouldn't be a problem, and you could see that the Bay Area would be crowded too because there's still a lot of teams that I didn't put in. I didn't put the Warriors, the 49ers, and the Mighty Ducks. Oh, I'm sorry, the San Jose Sharks. I didn't put the hockey team there. But that was just a quick and dirty demonstration on how to go out there then and to construct these cluster maps, dot maps. Okay, so based off the geography, where is the location of the 5 Major League Baseball teams in the state of California? So that's what this map is trying to show. And if we had more time, I would have done this for all the different professional sports teams, major professional sports teams, because I didn't put all of the different soccer teams that we have. I don't know what other professional sports we have in California. Okay, but I just picked the 4 major, and I didn't do all of them. I just did it for baseball. But this is the geospatial. So how about if what we have here, what is the exact description then? This is a geospatial mapping of the Major League Baseball teams within the state of California. So that's just a quick demonstration on how you would make these maps. Okay, so I'm going to stop sharing. I'm also going to stop recording.